This is the story of a machine that told its operators it was underdosing patients while it delivered 100 times the radiation they prescribed. It took 6 accidents at 4 different hospitals before anyone believed the machine could be wrong. March 1986, East Texas Cancer Center. A patient is on the table for a routine treatment, his 9th. The operator fires the beam. The console flashes an error. Malfunction 54. Dose delivered. Far too low, it says. So she does what she's done 100 times before. She presses P. Proceed. Every system fails. This is the story of how. The machine was the Therac-25, a radiation therapy system built by Atomic Energy of Canada Limited. 11 were installed across the US and Canada. It had 2 modes, a gentle electron beam used directly on the patient, and a high-power X-ray mode, safe only because a metal target sat in the beam path on a rotating turntable. 100 times the current. And the only thing standing between those 2 modes was the position of one turntable. Earlier models had hardware interlocks, physical circuits that made a mismatch impossible. The Therac-25 removed them. Safety was now the software's job, and the software was largely reused from the older machines written years earlier by a single programmer, never independently reviewed. The mystery is this: 5 times between 1985 and 1987, in 4 different clinics, patients were burned by a machine that insisted it had underdosed them. Marietta, Georgia; Hamilton, Ontario; Yakima, Washington; Tyler, Texas. Each time, the manufacturer investigated. Each time the answer came back: an overdose is not possible. 3 weeks after that March morning in Tyler, it happened again. Same clinic, same error code. A second patient, fatally overdosed. This time, the hospital's physicist, Fritz Hager, refused the official answer. He kept the machine, kept the operator, and asked her to do exactly what she had done, at exactly the speed she had done it. That speed was the key. She was fast. Experienced operators are. 8 seconds. That was the entire difference between a treatment and a tragedy. If the operator entered X-ray mode by mistake, then corrected it to electron mode within those 8 seconds, one task in the software missed the update. The turntable never moved, the target never entered the beam path, and the machine fired the 100x current straight at the patient. A race condition. It had been in the code for years. Here's the detail that should keep every engineer up at night. The same code had run on the older Therac-20 all along, with the same bug. On those machines, it blew fuses. Hardware caught what software missed. Nobody ever knew the bug existed. And it wasn't even the only bug. In Yakima, a different failure, a 1-byte counter in the setup routine rolled over to 0 every 256 pass. And on exactly that pass, the machine skipped its position check. Another patient overdosed. Another death. In 1987, the FDA declared the Therac-25 defective and forced a corrective action plan. Hardware interlocks went back in. 6 accidents. At least 3 people dead. The famous lesson is, test your software. That's not the real lesson. The Therac-25 didn't fail because one programmer wrote a race condition. Programmers write race conditions every day. It failed because every layer that should have caught it was removed or ignored, the interlocks deleted, the code unreviewed, the errors cryptic, the warnings so frequent that pressing P became muscle memory, and a manufacturer certain its machine could not fail. Safety was never a property of the software. It was a property of the whole system. They optimized it away. The postmortem is public. The lesson rarely is. I'm Sev. See you at the next incident.